All right, let's dive right into something that sounds like it's been pulled straight from a sci-fi novel, but might just be happening in a lab. We're talking about a kind of modern-day alchemy. But forget what you think you know about it. We're going to explore how to forge new elements using only sound.
So, let's just pause on that for a second. The question is a huge one. Can you really take one material, hit it with nothing but sound waves, and end up with completely different elements? I mean, on its face, it sounds impossible, right? It just seems to violate the basic rules of physics as we know them. But a very strange experiment suggests something else is going on.
So here's what went down. Researchers took ordinary liquid mercury and they blasted it with really powerful sound waves, ultrasound. And when they went back to analyze what was left, they found something that just shouldn't have been there. Traces of 13 totally new elements. And not just any elements, we're talking about things like gold, hafnium, and titanium. It's a result that honestly is pretty tough to explain.
Okay, so when you're faced with a mystery like this, where do you even begin to look for an answer? Well, the first big clue didn't come from any one element. It came when scientists looked at all of them together. A pattern started to emerge, a pattern that was so clear it couldn't possibly be a coincidence. And it pointed them in a very interesting direction. 100%. That's the number, that's the clue. Get this, every single one of the 13 new elements they found in that mercury is known to be a component of superconducting materials. Not some of them, not most of them, all of them. The odds of that happening just by random chance are, well, they're basically zero.
Now, the scientists behind this new theory put it in pretty technical terms. They said the distribution reflects a quantum selection rule. So what does that actually mean? In plain English, it means this whole process wasn't random at all. Something inside the mercury was actively choosing which new elements were allowed to form and stick around, and it was making that choice based on their very specific electrical properties.
And this is a really crucial point we have to get our heads around. This theory says this is not a nuclear reaction. It's not like the fusion you see in the sun or the fission inside a nuclear reactor. That stuff takes insane amounts of energy. No, what they're proposing is a low-energy, condensed matter effect. It's something that comes from how all the atoms in the liquid are behaving together. It's not about smashing atoms apart. It's about cleverly rearranging the matter that's already there.
So if it's not a nuclear reaction, then what on earth is it? Well, the paper proposes this really elegant mechanism called the Runaway Galvanic Boost cycle, or RGB for short. Think of it as a four-step feedback loop that might just be the key to this entire puzzle.
So the whole thing gets kicked off by this one principle. And it's something we already know happens. When you blast certain liquid metals with ultrasound, their electrical resistance just plummets. All of a sudden, they become way, way better at conducting electricity. This theory says that's the first domino to fall, the one that sets the whole amazing chain reaction in motion.
Okay, let's walk through this because it's pretty cool. Think of a snowball rolling downhill, just getting bigger and faster. Step 1, the ultrasound hits the mercury, and its resistance collapses. Now electricity is just flowing through it like crazy. Step 2, this superconductive environment creates a kind of electronic invisibility cloak around the individual atoms. Now, step 3 is where the magic happens. Any new types of atoms that try to form can only survive if they also help lower the resistance. And which elements do that? You guessed it, the superconductors. And that leads to step 4, the positive feedback loop. These new elements lower the resistance even more, which makes the cloaking effect stronger, which helps create more of the right elements, and the whole thing snowballs into what the paper calls a super-coherent state.
And here's the part that just makes you go, whoa. This completely flips how you think about it. The new elements, the gold, the titanium, all of them, they aren't some weird accidental byproduct. According to this theory, they are the exact ingredients that the system needs to create and maintain this incredibly efficient, ultraconductive state. They're not an accident. They are the recipe.
So, if it's a recipe, what can we do with it? Well, this is where the theory takes a huge leap, from just explaining something weird that happened in the past to actually talking about how we could engineer a totally new material for the future. It's about taking this knowledge and actually building something with it.
And they make this idea really concrete. By looking at the amounts of each new element they found, they came up with a specific formula. It's like you need a big helping of bromine. That's a key structural piece. Then you add a pretty good dash of titanium and just a pinch of hafnium. Each one acts as a dopant, playing a special role to get this new mercury alloy just right.
But the ultimate goal here, the real prize, isn't just to make a few atoms of gold.
It's to create a whole new class of material they call a dynamically doped liquid superconductor, or DDLS. The idea is to constantly dope or, mix in these tiny, precise amounts of new elements in real time. This creates a liquid with incredible properties we've just never seen before. A material like that could be a game changer for everything from energy transfer to quantum computing.
So this all sounds great in theory, but how would you actually build something like this in a lab? Well, this isn't just some daydream. The paper actually lays out a concrete blueprint for an experiment to create and control this new material. They call the setup tri-field activation. It's all about getting 3 different forces to work together in perfect harmony. First, you need an electric field, that's your voltage, to get the current flowing. Second, you need a powerful magnetic field to get the liquid mercury spinning really fast, kind of like stirring the pot. And third, the star of the show, the ultrasonic field. That's what kicks the whole process off and keeps generating that fresh supply of dopant elements.
And the point of bringing all 3 of those fields together is control. By perfectly balancing them, the goal is to lock the mercury into that special super-coherent state and just keep it there, indefinitely. You'd no longer be just watching a weird effect happen for a split second, you'd be actively maintaining it, turning the whole batch of liquid into this brand new, high-performance material.
And there's a really logical scientific path to prove if this is real. Phase 1 is simple. Just confirm the core idea. Does ultrasound really cause that resistance to drop in mercury? If that checks out, you move to Phase 2. Mix up the mercury recipe by hand, like a chemist, and test it. Does that alloy have the special properties they predict? And if that works, then you go for the grand finale, Phase 3. Build the full tri-field chamber and create this stuff in real time.
And that really brings us to the final and most exciting question. If this theory holds up, it takes a bizarre, unexplained anomaly and turns it into a powerful new tool for material science. What we could be looking at here might be nothing less than the blueprint for a whole new generation of engineered, high-performance liquid metal technology. And that is a truly mind-bending thought.